Yes, today we will be starting with the continuation of the same topic what we have discussed in the previous class, that is common source stage with source degeneration circuit. So this is the circuit what we have discussed so far, and this is the expression of the gain without channel length modulation and the body effect. The expression of the gain is minus gm into RD divided by 1 plus gm into RS. So there is no term R0 and GMB, which means it is without channel length modulation and body effect. So we before this is what we have discussed so far in the previous class, expression for the gain, and now continuing with this we have to discuss what is the output resistance of this source degeneration circuit. So now to find the output resistance we need to draw the small signal model for this circuit. So the small signal model is represented by this Gm into V1. So this is V1, this is RS, and the current flowing through the RS, take R0, and body effect, which is GMB VSB. So we have source Vx, and corresponding to this Vx we have Ix flowing through the device, and to the Rx this is the Ix which is flowing through the Rx. Since current through Rs is current through Rs is Ix, so we can write V1 as can be represented as minus Ix into Rs, because it is the voltage across. If we flip this resistance Rs, which will be the same voltage V1, the voltage across Rs and the voltage across V1 will be the same. So V1 voltage can be represented as Ix into Rx, and the Ix is flowing in the opposite direction, hence we have a negative symbol for current flowing Ix into the Rs. So V1 is minus Ix into Rs. Similarly for VBS, the dependent current source, GMB current source, which is dependent on VSB, is also represented by minus Ix into Rs. So this is now what we have equivalent voltage V1 and voltage VSB represented in terms of output current Ix and its corresponding resistance Rs. So now we will find out what is the current through R0. The channel length modulation what we have considered R0. So this is Vx, source Vx, voltage Vx for which the current Ix is flowing through that. And now to find out the current through R0, so current through R0 is given by the total current Ix minus Gm plus GMB into V1. Okay, so this is what you can see here. The current flowing through this is nothing but Ix. The current Ix is nothing but the combination of GMV1 plus the current flowing through the R0 and the current GMB VSB. Okay, so now for the current flowing through only through R0 is given by, so the total current Ix minus the current flowing through GM V1 and minus current flowing through GMB VSB. Since VSB and V1 are one and the same, so I have represented equivalently as V1, because we see VBS is nothing but V1 over here. So Ix minus GM plus GMB into, what is V1? V1 is nothing but Ix into Rs. Okay, so now the current flowing through IR naught, you see here the current flowing through IR naught, the current flowing through R naught is IR naught. What I have represented is Ix plus GM plus GMB into Ix into Rs. This is the current flowing through. Okay, so now to find out the impedance, or we see uh, that the output voltage or the voltage Vx, the voltage Vx is nothing but the voltage across R0 plus the voltage across the source resistance Rs. The total resistance, the total voltage Vx, what you see here, can be divided as the sum of the voltage across R0, which is nothing but V1, and the voltage across the lower resistance Rs, which can be represented as V R0 is nothing but I R0 into resistance R0 plus voltage across Rs is nothing but Ix into Rs. So this R0, what we have, we will substitute it here to this R0 as R0 into Ix plus GM plus GMB into Ix into Rs. This is IR0 plus Ix into Rs, this voltage. So total we have uh, Ix, I will take common, R0 plus GM plus GMB into R0 into Rs plus Rs. So in this entire equation I have taken Ix to be common, so Vx, so your resistance Vx by Ix, the output resistance Vx by Ix, so particularly Vx by Ix because we have the output voltage to be taken at this drain terminal. You see here the output is taken at the drain terminal, so the output voltage is with respect to the drain terminal, for which we have applied an external voltage Vx over here. Okay, so the output resistance which is taken at the output terminal or the drain terminal is nothing but Vx by Ix, voltage Vx, and the current due to Vx is Ix, is represented as R0 plus GM plus GMB into R0 into Rs plus Rs. So this is the output resistance of the source degeneration resistance circuit. Okay, so this is what we can approximate it to, taking R out, taking Rs to be common, 1 plus GM plus GMB into Rs, taking R0 to be common over here. This is the output resistance. And again, since this transconductance GM plus GMB multiplied by R0 will be very much greater than 1, so this into R0 very much greater than 1, we see that output impedance, so here we observe, so I will write it in the next sheet. Here we observe that the output impedance is increased by 1 plus GM plus GMB into RS. Okay, so usually the output impedance is represented by this R naught. Okay, the output impedance of the transistor. So now because of the source degeneration circuit, source degeneration resistance, the output impedance is increased by 1 plus GMB times of RS. So this is how the output impedance of the source degeneration circuit has been increased. So now again considering this output impedance, this is the output impedance expression of the circuit what we have asked for the test during test, and most of them has written the expression for the gain. So well, here the point you need to understand here is, so whenever you are asked to find out the output impedance, it is basically output voltage by output current. Note the point, output resistance is nothing but output voltage by output current. So here that's why we have added an external voltage source which is Vx, okay, and the current due to Vx is Ix, and that is what we have derived here, Vx by Ix, which is output impedance. And by this we have concluded that, so observation is the output impedance is increased by 1 plus Gm plus Gmb into Rs times of R naught. The output impedance of the transistor is usually R naught, which is nothing but the channel length modulation. Now that output impedance has been increased by this much times. Fine. So now continuing the same, so we will find out the expression for gain now. To find the expression for the gain, considering the entire circuit, we will draw the small signal model for the circuit, which is gate terminal. So this is V1, this is Gm into V1, this is R0, and this is body effect, which is GMB into VBS. Fine. And now this is load resistance RD, which is connected from drain terminal to VDD, which is during small signal model connected to ground. Okay, so this is RD and this is RS. This is source terminal. This is V1, this being plus and this being minus, and this is the current flowing through the RS. Okay, so now here we see that V out corresponding to this, the current will be I out, which is flowing in this direction. Okay, but we have the current flowing through in this direction, and this I out is nothing but what, V out by RD, I mean flowing through this resistance RD. Okay, so this is flowing in the upward direction, which is opposite to that of I naught. Okay, so this current which is flowing in the upward direction opposite to that of I naught is represented by minus V out by RD. So here I am just making a note that the current flowing through the RD, is minus V out divided by RD. Okay, so that is the current which is flowing through the resistance RD, and it is the same current which is flowing through the RS, which is minus V out by RD. Okay, so this is the current flowing through RS, which is same as current flowing through RD, which both are equal to minus V out by RD. Okay, so this is one of the representation what we take here. And now coming to the input voltage, what we have applied here. Here input voltage, this is plus and this is ground. So V in is nothing but V1 plus voltage across RS. So this total voltage from here to here, positive to ground, V in what we have applied is V1 plus voltage across RS. Okay, so this can be written as V1 as V in minus voltage across RS. V1 is equal to V in minus voltage across RS. So you are continuing this. V1 is V in minus voltage across RS is nothing but current through RS, which is minus V out by RD. This is the current and RS resistance. So this happens to be V in plus RS by RD into V out. Okay, so this is V1. We'll take this as 1. So now again VBS is VB minus VS. So body is anyhow connected to the ground, minus VS is nothing but the voltage across source resistance, which is nothing but the voltage across RS. Fine. So which is voltage across RS, which can be written as minus voltage across RS is nothing but current through the RS. Current through the RS is minus V out by RD multiplied by resistance RS. So here again your VBS is RS by RD into V out. Fine. So now again consider this as 2. Now considering current through R naught. Current through R naught, which I told represented as I R naught, is nothing but Ix. In the previous case what we have taken is nothing but V out by RD, output current. Here this is the current, minus GM into V1 plus GMB into VBS, this both in the bracket. Okay, the current flowing through this R naught is nothing but the total current, which is minus V out by RD minus this current GM into V1 and this current GMB into VBS. Okay, so now solving this, we get minus V out by RD minus GM into V in this. I am substituting this V in from equation 1, V1 as V in plus RS by RD into V out plus GMB into VBS by equation 2, which is RS by RD into V out. Okay, so this is the current IR naught, which is finally minus V out by RD minus GM into V in minus GM into RS by RD into V out minus GMB into RS by RD into V out. Okay, so now the output voltage, so the output voltage adds up across R0 and RS. So V out is nothing but voltage across R0 plus voltage across RS, which we get as IR0 into R0 plus IRS. I is RS is nothing but V out by RD in the opposite direction, that's why minus V out by RD into RS. Okay, so now continuing the same and substituting for this V out is equal to R0 into IR0, where IR0 is minus V out by RD minus GM into V in minus GM into RS by RD into V in, sorry, GM into RS by RD into V out minus GM B into RS by RD into V out. This total is IR0 plus minus V out by RD into RS. So this is the IR0 what we have substituted in the place of this IR0. Okay, so that is V out is IR0 into R0 plus minus V out by RD into RS. Okay, so continuing that, we have substituted this IR0 in this equation, 3, and we got the final output expression. So taking V in common among this, and taking out the expression for V out by V in, which is a gain, is happens to be GM into R0 divided by 1 plus R0 by RD plus GM into RS by RD into R0 plus GMB into RS by RD into R0 plus RS by RD. So this is the overall expression of the gain for common source amplifier with the source degeneration circuit. So taking the LCM and substituting for altogether, we will get the expression for gain, which is V out by V in as minus GM into R0 into RD whole divided by RD plus RS plus R0 plus GM plus GMB into RS and R0. Okay, so here, so this is the total expression of the gain of the common source stage with the source degeneration circuit. So and again we observe that, so this expression RS plus R0 plus GM plus GMB into RS R0, this is nothing but the R0 R out of the MOS device with degenerated resistance Rs. You see, so this expression you see here is nothing but R out of the MOS device with degeneration resistance, that entire term what you see here. This we have derived in the earlier now, right? So this is the expression of the gain what we have considered here for the common source stage with degeneration resistance. So continuing this, if I take the same expression, this Rs plus R naught plus Gm plus Gmb into Rs R naught as R out, and multiply it and divide it with the same term. So this V out by V in, continuing the same, minus Gm into R naught into Rd divided by Rd plus Rs plus R naught plus Gm plus Gmb into Rs R naught, multiplying and dividing it by this term which is R naught as Rs plus R naught plus Gm plus Gmb into Rs R naught divided by Rs plus R naught Gm plus Gmb into Rs R naught. I am just multiplying and dividing it by that term. Okay. So now with this, what we observe here is this entire term. I will replace it and write it as R out of the MOS device with degeneration resistance Rs. So this entire thing as R out, and this entire thing is R out. Okay, so this can be rewritten as minus Gm, this is Gm into R naught, okay, minus Gm into R naught Rd into this term, this entire term as R out of the MOS device with source degeneration resistance Rs divided by Rd, this term, plus Rd plus this R out. Okay, Rd plus R out, this entire thing is R out, and this R out as it is can be written as this term. This term can be represented as both Rd and R out are parallel to each other in this expression. Okay, so remaining term minus Gm into R naught is divided by R out. So this term Gm into R naught divided by R out is nothing but the transconductance of the device including source resistance, transconductance of the device including source resistance, that is degeneration circuit, which is minus Gm into Rd parallel with R out. This is the same equivalent representation of the small signal gain of the common source amplifier, provided that here including source degeneration circuit we have obtained this transconductance to be Gm, capital Gm, which is nothing but represented as minus Gm into small r naught divided by capital R naught, where this R naught what we have derived to be the R out is nothing but it is the output resistance of the MOS device with source degeneration resistance. So finally So this is the expression of voltage gain of common source stage with source degeneration circuit. Fine. So these are the observations what we made in this. So we will stop here and continue it in the next class.